In our next problem, we are given that there is an unknown compound which has 69.77% of carbon, 11.63% of hydrogen, and has a molecular weight of 86. The rest percentage is covered by oxygen. The molecular weight is 86. It doesn't reduce Fehling solution and it gives positive iodoform test. We need to find the possible structure of this organic compound. Now for solving this problem, let us make a table. Element, which are carbon, hydrogen and oxygen. Percentages, which are 69.77, 11.63, and the rest, on subtracting from 100, we get 19.20 percentage. The third column will be relative number of atoms, and the fourth column will be of simplest ratio. The approach of this question is, we'll first find out the empirical formula of this compound, and from this empirical formula we'll find out the molecular formula of the given compound. The relative number of atoms are found by dividing the percentage by the atomic mass of carbon, which is 12, and hence we get the relative number of atoms of carbon as 5.81. The relative number of atoms of hydrogen will be 11.63 divided by the atomic mass of hydrogen, which is equal to 1, so we get 11.63, and similarly 19.20 divided by 16, which is equal to 1.20. The simplest ratio will be obtained by dividing each of these three by the smallest of the three. The smallest is 1.2, so dividing each of these three by 1.2, we'll get the simplest ratio of carbon as 5, of hydrogen as 10, and of oxygen as 1. We take these numbers as the closest integers which are present. This is 5.81 divided by 1.2. It is actually not equal to exactly 5. It is approximately somewhere nearer to 5. So we take the simplest ratio as 5. Similarly, this 11.63 divided by 1.2 is not actually equal to 10, but we take the simplest ratio as 10, and hence 1.2 divided by 1.2 is equal to 1. Hence we have got the simplest ratios of carbon as 5, hydrogen as 10, and oxygen as 1. The empirical formula is obtained in the following manner. We write the simplest ratio of carbon as 5, then hydrogen as 10, and oxygen as 1. This is C5H10O. Now we are trying to find out the empirical mass of this compound. The empirical mass is 12 into 5, 60, plus 10 into 1, plus 16 into 1. So this comes out to be 86. And we are given that the molecular mass of the given compound is also 86. This is the empirical formula of the compound. So the molecular formula of the given compound can be written as C5H10O into N. Since these were the smallest, simplest ratios, hence 5N, 10N and N, when taken in this formula, C5H10O whole N becomes the molecular formula of the given compound, and this N is obtained by molecular mass upon empirical mass. Our empirical mass comes out to be 86 and molecular mass is also given equal to 86. So we have N equals 1. Hence we have empirical formula equal to molecular formula. Since this organic compound contains carbon, hydrogen and oxygen, and since it gives positive iodoform test, so it can be an aldehyde or a ketone. But since we are given that this compound does not give Fehling solution test, so it cannot be an aldehyde, because an aldehyde never gives Fehling solution test. So this is a ketone, and since it gives positive iodoform test, so it should have CH3CO group present. So now we try to find out the general structure of C5H10O. It can be CH3, C double bond O, CH2, CH2, CH3. Here we have got 2 carbons, so attaching 3 more carbons to this. The simplest carbon change is CH2, CH2, CH3 to obtain this ketone. And the second possible formula or the structure of the ketone can be CH3, CO, CH, CH3, CH3, attaching both the methyl groups to this C carbon to get the second possible structure of our ketone. Hence the 2 possible structures of ketone possible in this question are CH3CO, CH2, CH2, CH3 or CH3CO, CH, CH3, CH3, and this is our final answer.